to require manual proof. Yes, that's a solution. That's a solution. That's a solution. But let me give you another solution. Maybe you've heard of it, okay? Which is the account abstraction and the multi-party computation, okay? So exactly, Ale, you're talking right. So for that, let's talk about something, a standard called the ERC-4337, okay? You already know about this standard, by the way. I think you probably heard of it. Human in the loop. Yeah, I agree. Sometimes a human layer must be an obligation in some use cases. Unless you put like very clear restrictions to your AI agent. Because if you do clear restrictions to your AI agent, a lot of things or a lot of problems could be avoidable. Okay. So yes, yeah, we have somebody who already heard about ERC-4337, so it's good. So traditionally, yeah, let me walk you through this. So traditionally, like every Ethereum wallet is in EOA, okay, which stands for an externally owned account. So this account, it is controlled by a private key. Okay, we are all agreed on that. ERC-4337, which is the standard, flips this, because instead of the AI holding a private key directly, the wallet is a smart contract. So the AI submits something called a user operation. Think of it like a signed intent, and a network of bundlers packages that into a real transaction, okay? Let me give you an analogy. So think of ERC-4337 like a corporate expense card with built-in spending rules. The AI can use it, but the contract is the card issuer. So it can say no, the transaction exceeded your daily limit before anything hits the chain. Okay? Yeah, it is a standard. It is a standard. Okay? So yeah, let me put my glasses, sorry. So the real magic in here is gas sponsorship, okay? So the agent doesn't need to hold ETH to pay for its own transactions. So a paymaster contract can cover fees and batching, by the way, multiple actions in one atomic call. So if step 3 fails, the whole batch reverts. So there is no partial states or orphan instances, okay? So yes, that's very important. That's a solution. And the other thing, it's called the MPC, not MCP, guys. It's the multi-party computation. Now for the key management side, like MPC stands for, like, as I told you, multi-party computation. So the idea that the private key is mathematically split into shares and distributed to different parties. So no single share can sign anything alone. And by the way, I have a story. I don't know if you probably you already know Vitalik Buterin, the founder of Ethereum protocol. He uses this, okay? His private key, which contained like the private key of his wallet, which contained like 100% a lot of money. It is not in the same place. It's divided into multiple people. Like there is like a part of the private key at his mom, another at Russia, etc., etc. So it is split up all across the world. So in order, it feels like a puzzle. So in order to hack his wallet or get his private key, you need to grab all the pieces together. Okay, so yeah, it is an example. Smart contracts, but it should handle the cases of hallucinations. Yeah, we will talk about that. Yeah, the best friend. Yeah, we will talk about that, by the way. We'll talk about that, the hallucination. Let me give you another analogy. Maybe it's very, you could relate to it more in these days. Let me give you an analogy. So The whole thing, it's like a nuclear launch, okay? You're requiring two keys turned simultaneously, okay? Simultaneously, okay? But in the same time, they are mathematically. The full key never exists in one place. So the AI will hold one share, maybe your team will hold another, and another party will hold the third. This is how we do things. We split the private key into chunks and we distribute it. It's like a multi-sig wallet, okay? In order to sign a transaction, you need all parties to sign the transaction in order for the transaction to. Yeah, exactly, Nadir. It's kind of the same concept, okay? So the critical point in here that the raw private key never exists in memory at runtime, not even for milliseconds. So tools like Fireblocks or Web3 Auth, like they are trying to implement this today. This is a production ready, by the way. Okay, so to summarize segment one, which is the MPC and the ERC-4337, the agent's wallet is a smart contract. It's not a wallet, okay? So it is a smart contract with programmable rules. So it differs from a person's wallet. It's very different because the wallet right now is a smart contract. And when we say a smart contract, we say programmability. So we say rules. We can define rules in this smart contract, aka the wallet of our agent. So I think like this, problem solved. So ERC-4337 handles that. And the signing keys are distributed across multiple parties using MPC, so there is no single point of failure or SPOF. So two independent security layers that goes in parallel. Okay, so is there any question, by the way, before we move on? Yeah, lit protocol as well. Yeah, lit protocol, exactly. Yeah, I skipped that. Yep. So basically, yes, exactly. Yes, you can see it like that. You can see it like that. All right, let's go to segment two, which is read, think, act, which is the execution loop from data to blockchain state change. Okay, so let's talk now about the think. But first of all, let me give you a small introduction on this chapter. Before an agent can do anything, it needs data. I think we all agreed on that. So where does that come from exactly? So there's two main sources. We have oracles like Chainlink or Pyth, or there is a lot of others, but these are the famous one that push real data, like real world data on chain, like price feeds, sport results, weather, whatever you like. And the agent queries these contracts and gets reliable data. The second source, we have indexers, like tools like the Graph, Gold Sky as well. Like they crawl blockchain history and let you query it like a database. Okay, instead of like replaying 10 million blocks. Of course, depends on the blockchain. You ask, give me like, for example, all Uniswap swaps over 100K or something like that in the last hours, and they give you the data. Okay, Oracle is a big issue. Just this couple of days, Aave lost millions because of oracles. Of course, it could be like these kinds of problems. They could happen every day. We are never safe, by the way. Okay, and these kinds of problems, like they happen like frequently. The thing about MPC though is that computation is super secure and happens inside the trusted platform module. chip on the motherboard, if I'm not wrong. Yes. I think, Ale. I'm not sure what, but I didn't do this part of the research, but I will look to it and maybe answer you later. But I think it makes sense what you said. Yes, definitely. But yeah, talking about oracles, by the way, oracles, for those who don't know oracles, they are like a live news ticker, okay? Real-time feeds, indexers. They are like newspaper archive, okay? And agent, like, they need both in order to make accurate answers and do like what they have to do. So the agent also listens to events, okay? Smart contracts emits like events when things happens, and a token transfer or a vote cast or a price moving past the threshold or whatever, okay? The agent subscribes and wakes up only when relevant things happen. So, which is, by the way, much more efficient than like polling every block. So this is the read, okay? This is the read. This is how the agent read. If you rely on oracles, doesn't that mean that you rely on centralized party? Correct and not correct, because oracles, they are not very centralized. They are decentralized, and that's their unique purpose, I think. Okay, but I agree with you that there is a bit of centralization in some oracles. And the fact that you are using only oracles, you are centralizing the whole thing. That's correct. But these things, guys, they are very theoretical for now. It could be like, yeah, a research study for maybe some PhD applicants right now or candidate, but yeah, we are still trying to find new design patterns, new architectures, etc., etc. This might be not the most optimized solution for now, but this is the only working solution for now. Maybe in the future we will see new things, and it's definitely gonna be the case. But for now, this is only like what we have right now, at least. But yes, your point actually stands. Okay, let's now move to the think. So, which is the LLM decision layer. So now the data hits the LLM, the agent receives like a structured prompt, and here's the current state. Like here's, for example, the goal. Here's your constraints. So the LLM returns a decision, okay, and call like for example, and it will return like a structured output. Call function X with parameter Y, or yeah, I don't know, escalate to human, for example, if there is a human intervention needed, okay, or for example, wait for the next block or whatever. So this is the think layer where the LLM gets the data, thinks, and after that, we will be talking about the act, which is triggering an action. Okay? So the key point in here, this is not the LLM just chatting. The LLM is like a reasoning engine called as a function. Okay? Its output is a structured action, like a JSON type of thing. Okay? So the agent framework then routes that action to the right tool. Think of it like, yeah, you are communicating via a standard. And by the way, there is a standard in Hedera, like which is the HCS 11 and 10. Okay, these standards, they are made in order in order for the communication of agents between each other. Because imagine these agents, they need a language in order to communicate between each other. So they created the whole language in order to achieve this communication. It's the same thing. Okay, in order to communicate with an application or an algorithm, you need to create a language between them. And this language, it's called a JSON, because with the algorithm could parse this JSON, and yeah, like according to the instruction of the algorithm, he will execute actions. Okay, so yeah. Now let's move to the act part. So the third step, which is broadcast to chain. So the decision is made. Okay, now the agent acts. It encodes the function call, like ABI encoding. Okay, signs via MPC or account abstraction, and broadcast to the network. Okay, and by the way, here's where network choice matters enormously. On Ethereum mainnet, like a microtransaction that costs like, I don't know, like $1 in gas is like economically viable for an agent that runs 10 times a day. Okay, but it's completely unviable if it runs 10K times a day or 10,000 times a day. So that's why, like, there is difference in different infrastructure. For example, if we're choosing Hedera with sub-cent fees and or for example layer 2 rollups, they already exist, like it could be more efficient. Okay, so agent can run execution loops at high frequency, making agentic micro economy like actually work. And that's how you do it for now. Okay, what do you think, guys? If you okay, there's some questions. The thing about yeah, we already read that. Okay, so if you rely on Oracle, yeah, there is no question. So okay, so I think there is no questions right now. I think this part is very, very clear. So let's move to the next section, which is guardrails and security, and it is actually very, very important. And by the way, next session I will show you maybe how to create an AI agent, okay, that executes transactions. Okay, so it's very important that you understand this. Cool. So very clear on my side. Thank you, Yusuf. Thank you, Yusuf. So segment 3, and I want to be honest with you, this is the segment like most teams like skip in the early days. And yeah, it's very important because they're gonna regret it. Okay, because yeah, which is guardrails and security. What like stops an AI agent from draining its own AI wallet? Like, have you asked this question? It's a very important one, and probably anybody would ask it. Like yeah, and Didi was talking about hallucination like earlier. Okay, or what's gonna stop an AI agent, like for example, to make a $2 million trade when it meant to make $200 on profit? Like risk wise, it's very immature and irresponsible. Okay, or for example, getting manipulated by a malicious smart contract, a code. Okay, so all of these things, they could happen. Okay, and that's why security and guardrails are very, very important. And before like monetizing any AI agent that you are developing, you need to focus on this part because it's the most important one. So yeah, correct. So let's talk about that. Is there any question about this part? I think we already discussed this earlier, so I won't get back. So it's okay. So as you can see in here, the first line is, yeah, where am I? Sorry. Yes. So we have maximum speed per transaction, okay, which is hard-coded ceiling. If the LLM encodes a transfer of 1000 ETH and the limit is 5, the transaction needs to revert. Okay. Daily or weekly caps. So I'm trying to explain to you what we need to put on our smart contract. So yeah, I already told you about the maximum spend per transaction, The daily or weekly cap, so the contract tracks cumulative spend per per rolling window, resets it automatically via block timestamp. Also, we need to have whitelist of recipient addresses. Like the agent can only send funds to pre-approved wallets. New addresses require, like, for example, a multi-sig approval or whatever. Also, we need to put time lock delays. Transaction above a threshold amount get queued with a, I don't know, 24-hour delay, for example. And we always give the human time to cancel this transaction if it is malicious. Also, we need to implement the pause function. Like a multisig can freeze all agent activity instantly, like an emergency stop. And there is very good design pattern in Solidity, by the way, that you could use in order to implement these security codes in your smart contract. Okay, so let me say it again. We have the pause function, the time lock delays, the whitelist in order to whitelist the addresses and maybe blacklist others, the daily or weekly, even monthly caps, okay, and the maximum spend per transaction. You need to put these rules. Okay, imagine giving like infinite maximum spend to your AI agent, he could use the whole balance. So in order to avoid AI hallucination, or let's say if hallucination occurred, let's say we are using a very bad LLM, at least we minimize losses. Better use a transaction with $20 than using, like, spending a transaction with $2,000. Okay? What else? Also, human in the loop for fallbacks. These are very important. So, anomaly detection. If the agent's behavior suddenly deviates from baseline, for example, it usually spends $50 a day. Today, it wants to spend $50K. So automated monitoring flags this and pause execution, and you need to review the smart contract and review the code of your agent. Also, we have approval webhooks. So high value action, they require explicit human sign off via a webhook before the transaction is signed and broadcast. Also, we have fork simulation. So before broadcasting to mainnet, the transaction is simulated on a forked state. And if simulation fails or produces unexpected outputs, the agent aborts. Okay. Also, and of course, audit logging, and that's the purpose of logging, by the way. So every decision and every transaction is logged on chain or in an immutable off-chain store or whatever. Okay, so that gives you full traceability, and this matters for compliance and especially for debugging. Okay, so these takeoffs, they are very, very, very important because together they shape the security and, let's say, the layer of security of your smart contract in order to avoid things that could drain your wallet, okay, or make your wallet compromised. Okay, so is there any questions? Yeah, I think, by the way, this is the last thing. Okay, maybe now if you wanna brainstorm, if you have any community automation ideas, yeah, feel free to share with me your ideas. I won't talk about mine because I already shared with you a lot of ideas the last session. But if you have some ideas, let's explore them together. Okay? We only have 10 minutes left, so feel free if you have some interactions, maybe some ideas that we could discuss. It could be interesting for everybody. Did you work on agentic finance and tested it? It's efficient. Is it efficient? Agentic finance, actually, imagine a wallet, like an agentic wallet, like making trades for you and making profits for you, and your yeah, hanging around or doing anything of your choice, okay, and you have money profits in your wallet. Like that's something very cool. Like that's something great. Okay, so the potential is huge. It is very big. It's very big. Sometimes it sounds too good to be true. Of course, there is sometimes gaps, but guys, come on. Like we saw a lot of hackathons, like doing these kinds of agent competitions. Okay, they are like testing a lot of agents and giving them like a balance of $1,000, and they will give them like a timeline like 20 days or something like that, and they will see like how much these agents are efficient. And we saw a lot of agents made like very good profits. And by the way, a lot of these agents, they are open source, that you could install them maybe and use them for your own good. Okay, so yes, it works. It works, and it's actually feasible. And the most important thing, it is improving, guys. It is To be honest, I'm wondering what's our purpose in the future. If we have AI agents making money for us, if we have everything done by the AI, like what's our purpose? I don't know. I don't know. I still can trust an agent to do financial transaction on my behalf is good until it fails horribly. I know, but probably, Ale, probably with the security layers that we talked about, okay, it minimizes the risk. Because imagine that you started with a wallet like you have $20, and after 30 days now you have $300. So you've made good profits, okay? So it's good. It's good for you. And in the smart contract, you are saying to the agent that, yeah, please don't do transaction above $20 or $10. So like that, you are monitoring the agent. If you are like seeing the agent going like sideways, you could always have the possibility to pause it. So there is no flipping in this case because you are minimizing the risk. All right? So using these habits and using these like standards, you can optimize the agent. We cannot blame the agent at the end because after all, it's an AI. Okay, we cannot blame it, but we can use it. Okay. Can we have an example of those agents? Yeah, the agentic wallets. Like agentic wallets are one of the most important one. Okay, let me give you this one. For example, an agent. By the way, there is bots for this, but I will give you maybe some. Yeah, let me give you the same example. So, do you know DNS guys like google.com, youtube.com, like these links, okay, they are called DNS or domain name systems, okay? And the DNS, they are yeah, you could trade DNS, okay? And there is bots who buy these DNS in order to sell them for profit later, okay? You could, for example, create an AI agent that like try to fetch cool DNSs, something like that, or maybe try to fetch like a new blockchain with a new naming system and try to buy the most like popular one, and after that sell them for a profit. Okay, so you have an agent that will buy these DNS, okay, DNSs, okay, and buy them after that for profit. So that could be an idea, okay. But imagine like everything that could be automated and needs payments in it. It could be an idea to create an agentic wallet or an agentic AI. Okay, so yeah, Ferok, we watch AI. Yeah, that's sad, bro. Very good question. Thank you. What will be our purpose in the future? Yeah, that's something that, yeah, probably, yeah, go watch Black Mirror. It's it's a TV series. It probably resumes all our future. Now imagine if you started with $300 and after a few days you wind up. Yeah, but I think you will notice that. You will notice that because if you put a threshold of $10, you need at least 20 transactions in order
to smell that something is fishy about the AI agent and is doing bad decisions. So you can stop that at any time. Okay, so I think it's avoidable by setting rules to the wallet. Yeah, like giving an AI agent a wallet without rules is a bit kamikaze. Okay, so the best practices is to set rules before doing like giving an AI agent a wallet full of liquidity. Okay, no, that's for trading. Okay, I think some AI agents now have identity files and restriction files. It's in there. It's in there. We put our limitations, such as the one mentioned $20 limitation. They are always sent in the context to prevent wrong misbehaviors. Yes, yes, of course, of course. But in here we are using the blockchain infrastructure. Having a smart contract with specific rules deployed on chain, an immutable chain, is more secure than just putting restrictions in some prompt engineering layers. Okay? And more than that, these restrictions, because after all, the smart contract is, of course, it is the wallet. Okay, it is the funding wallet, and of course, it contains the rules. Okay, and it contains also the tools. Okay, and you are giving your AI agent the exact tools in order to execute the exact task. So by forging a smart contract with very strict rules, you could maybe try to control your AI agent better. That's what I think. Last one, mess. Yeah, probably mess will never come back, bro. Just try to forget about it. Okay. The higher the risk, the higher the reward. Yeah. Yeah, if you have some mass, yeah, you could try to trade with it or use an AI agent in order to trade with it. Anyways, if there is no questions, I think we can. Yeah, I think we have more questions. Feel free if you have ideas, guys. We could share them together. We still have 5 minutes, so we can still maybe talk about other things. Example of successful AI agent that we can look into. There is a lot. There is a lot. Let me maybe do just I listed them just a second. There is a lot, by the way. There is a lot. I think there is Octopus. It's an AI agent wallet or agentic wallet. Octopus, I think it's called, or Octopus. Yeah, I forgot about it. But it is a wallet controlled by agents, AI agents, and these AI agents. There is multiple AI agents. There is future AI agents, spot AI agents, DeFi AI agents, and they are executing transactions every day, and they are trying to make profits for you. And there is, yeah, Fetch AI. I think Fetch AI. Also, we already talked about it, which is one of the most mature deployments, by the way. Like, you could maybe take a look on it. Singularity, yeah, Singularity. I forgot about Singularity now, guys. Go check it as well. Eliza OS, by the way. Yeah, you could check Eliza OS. It's 2024, by the way. Huh? It's not new. So they launched an AI-based investment DAO like 2 years ago, I think. So yeah, go check Eliza OS as well. Like virtuals, I think. Yeah, virtuals. Virtuals is also a very good use case that you could look to it. What else? Like, this is what I think of right now, but there is a lot of use cases. You could do your own research, but there is a lot of use cases already deployed and people that are using these use cases. Another automation idea is an agent that manages tokenized real world assets such as tokenized stocks. It can execute smart contracts to buy, sell, or rebalance positions automatically, and if market volatility rises above a certain level, the agent moves funds into treasury-backed tokens for safety. This is essentially what I am trying to build with Hedera Autovest AI. What's your take about this? It is a very good idea. it is a very good idea because it solves a real world problem. Okay, a lot of people like having these kinds of problems, so it is a pretty good idea in my mind because it solves a problem. So it is a solution for a lot of people. So if you do it the right way, yeah, it will be a very successful one. It's very good, Emmanuel. It's very good. Yeah, you heard a wallet called Mariposa. Yeah. I know that wallet. It's a very good wallet. It's an agentic wallet, guys. It's an agentic wallet. But Emmanuel, it's a very good idea. It's a very good idea. I think these kinds of ideas like they works. Okay. Do you remember like the token Trump token? Like for the majority of people, like when the thing happened, they were sleeping. Okay, because yeah, there is a big gap between the US and us in the time zone. So when the pump happened, like the majority of people were sleeping. And when we woke up in the morning, new millionaires they are born because this token pumped like crazy, like crazy. So only few lucky people bought this token and they made huge profits. Okay? Um if maybe you had an AI agent that scouts on social media and probably try to look for new tokens or something like that, he will probably spot this token and buy some of it, like buy the dip. He will buy the dip, like just in the bottom before he pumps up. So imagine waking up in the morning having like I don't know, like a lot of money because your AI agents made you this profit. It will be very good. It will be the best morning ever. Cool. Thank you for the feedback. Thank you as well, Emmanuel, for sharing. I remember Trump. Yeah. It was a very big event. Yes, honestly, I was speaking then. Okay. Yes, take a look on the use cases, digital calligraphy that I told you about. Something is bugging me about the whole AI in the finance thing. I mean, there are mathematical statistical models that are able to do some kind of forecast and define trading strategies, etc. Like Bloomberg, has been doing this for years now. Then why do we need AI in finance if we have some more deterministic way to trade? Yeah, bro, you always ask me questions that I don't know how to answer. Probably the future will declare this, okay? But but yeah, I think I see in your like from a different point of view, like your point stands. It stands. But I guess we will see how things will turn in the future. We don't know. We don't know. But yeah. I don't know. Yeah, maybe talk. Yeah, maybe talk with. I mean, he presented like he proposed to me to talk about AI and blockchain. So this is how what I made, guys. Sorry. Yeah, this is all I know. This is all I know. This is my knowledge. This is all I know. Maybe Amin will share with you. Like he has this pretty good idea to talk about this topic. Okay, it is a very good topic. Don't get me wrong, but it's very theoretical. Okay, it's very theoretical because we don't like even the use cases that works right now. They are good, but not good enough. Okay, but in the future, like something will happen. And you will remember maybe this session. Jump on stage. Do you need you, please? Yeah, you have to talk with the guys. I mean, thank you so much, guys. So I think we finished the session. Thank you for interacting. Okay, it's much better like this. Uh, so yeah, thank you so much. And I think we can close the session if there is no more questions. Thank you, Ale. Thank you.